My name's Tim Rupp, Principal Software Engineer with F5, and I'm the one that is basically responsible for writing a lot of this stuff. So if you're going to be using the F5 Ansible modules, you've probably used my work. And then we have another person that has recently started assisting with the module work. He is over in London right now. So,
I am Forrest Crenshaw. I'm a product management engineer over automation and orchestration, primarily focusing on Ansible and AS3. Let me just plug this in real quick so I don't go to sleep in the middle of the presentation. All right, so what we're going to go over, we're going to go over a high-level discussion of basically automation and primarily Ansible within that. Then we're going to go over an Ansible crash course with Tim. We're going to go through a few demos of licensing, HA pairing, and end-to-end app deployment, including an AWS EIP, and it should hopefully be accessible to the class afterwards, and then some common debugging issues that we run into. So what is Ansible? Well, it's a general purpose tool for deploying automation against host boxes. So in our case, big IPs, but it doesn't have to just be big IPs. It has a large following, mainly because it is agentless. It makes it a lot easier, nothing to maintain or update on all your devices throughout your network. You get abstraction away from complexity of potentially the APIs of the devices you're trying, or the software you're trying to provision on the boxes. So in our case, if you're trying to provision load balancing or ADC, WAF, you have it. You no longer have to know all those REST API endpoints anymore. The modules will do it for you. And then it is extensible. It is modular. And so you can, I'm sorry if this is kicking back. You can define the task order of what you're trying to get done on your remote box. So in this instance, you create a pool, add members to it, create a virtual, add the pool to the virtual. And you can add and remove tasks in that. So if you want to add tasks for running a Docker image in that, you can do that if it suits the needs of what you're trying to get done. So why is this important? Well, our most constrained resource is our time and the people and their time performing actions on our as NetOps engineers. So if we can get more value out of our time by automating and orchestrating our systems, then we can have a competitive advantage in the market. So this is kind of a summary of what we were just talking about. Simple, powerful, and agentless. No special coding skills. You have to understand YAML, but that is very similar to JSON. It's just a file structure. The tasks are executed in order. It's going to help you do app deployment, configuration management, especially when you start talking about infrastructure as code. And it's the agentless architecture. And again, here highlighting the abstraction layer hides the REST API complexity. So Ansible has a triple for loop, and actually I'll just bring all three up. And next to it, and Tim will present more of this later, so you don't have to memorize what's going on here, but what's happening is you have a playbook which says what I want to do, and for each play, for each host, for each task, an action's being done. So at the top you can see here, there's a play, which is provision my big IP, the first, and then there's a grouping of hosts, which big IPs is a variable, and that could represent one box, a grouping of boxes, but something that you want to perform all these tasks against. Then each task, set NTP server, set DNS server. Now this is a very basic example with hard-coded parameters. But then, and they don't have to be, by the way, but it's looping through for each play, for each host, for each task, it will take this action. So traditional Ansible running against a host machine, say if you want to move files over to a box or run Apache on a server, your laptop or your Ansible host machine, so in this case our laptop and the demos we'll be doing, but whatever's running Ansible takes two inputs, or two primary inputs, a host inventory file, which is what I'm manipulating, and then a playbook, what you want to do to those hosts. It then moves it over to the box you want to manipulate and runs it there over SSH. And this is the key difference, is when we look at the big IP side, the Ansible management node is actually making an SSH connection back to itself and then using REST API to go manipulate the big IP. So that's the primary takeaway. That remember, if you're manipulating a network device or such as a big IP with Ansible, the box is actually connecting it back to itself. And again, in our demos, we'll highlight something about a Python virtual environment where it's important to keep that in mind. And then our module workflow. So Tim, being one of the primary developer of our modules, has followed a strict guideline of how to develop our modules, and so we get expected outputs. Our modules, we take our parameters from a big IP we want to manipulate, and the module parameters. We check to see if that object exists on the box already. If it doesn't, we create it. If it does, we figure out if there's a difference that we need to update and notify the user of. So say you just updated the port of a virtual server. It would notify you that that change happened, but the rest of it's idempotent. So it's not wiping away the virtual server just because you've changed one parameter. It's only making the difference. And whenever the big IP decides it needs to reach out, or whenever the Ansible module needs to reach out to a big IP, these are the functions that it's running, and Tim actually wrote these, so I'll let him speak to them a little bit.
Yeah, so this slide and the previous slide, we're really including them for the people that want a little more technical depth in explaining the modules. We get a lot of questions on like how the modules are actually communicating with the device and doing their work. And in summary, it's these 4 functions up here that you'll find in every module that are responsible for communicating with the device itself. The block diagram that we saw previously, it's the same process followed in all modules, and this really allows us to move fast, to put more features into Ansible, because we don't really need to decide how we're going to execute that pipeline in the module. We know that already, so we just need to figure out what the REST APIs are that we need to communicate with, and then the things that are the quirks or changes in that particular REST API. Once we pin that down, the module is pretty much ready to go. And this has allowed us to churn out the volume of work that we have in the time that we have. So I'm going to give everyone here a crash course in Ansible. This is the F5 version of the crash course. There are other presentations, I think, that have touched upon the basics. Who all here is like familiar with Ansible? Okay, and you've used it in-house and stuff like that? Okay, cool. So some of this might be like rehashing, or you might know this already, but I just want to reiterate it because when you interact with like my team or F5, we are going to expect you to behave in a particular way, and and we want you to know some certain terms and stuff so that we're not getting each other confused on what we're talking about. So in terms of installation, Ansible can be installed a number of different ways. Some of those ways are mentioned on Ansible's website or their GitHub page, but as far as F5 is concerned, there's only one way to install Ansible, and that is pip install Ansible. We don't do any development or test or nothing with package managers, and there's a reason that we use pip, and in particular that's because when Ansible is doing development of stuff, if there's new features or whatever that we want to make use of, you can instruct pip to get that development software in the same tool that you would use to get the stable software. Another reason is that package manager, the maintainers of packages typically lag behind the official releases, and Ansible's official releases are distributed here. To use the F5 modules, there are some dependencies today that need to be resolved on your Ansible controller. Many of these are going away, just as we're making an effort to make it so that you don't have to install dependencies to make our modules useful. The F5 SDK is one of those dependencies that's still required. However, the Python NetAdder library is one that will disappear in Ansible 2.7. So that will no longer be needed. Additionally, Big Suds, which is a library some of you may be familiar with, is required for at least one module up until Ansible 2.7, and then it'll be gone. So Ansible 2.6 was just released, and 2.7 will come out, we believe, sometime in October. And so one of these dependencies will fall off the chart, and you'll just be left with this one. Longer term, we're also going to probably get rid of this one because it actually generates a significant number of support requests. And that's one of the troubleshooting tips that we'll go over. So core concepts. In Ansible, there are 2 big things that you have to be aware of. One of them is the playbook. And a playbook is composed of plays. Those plays are composed of tasks. Tasks are composed of modules. and modules have parameters. Okay, and that's Ansible's lingo. That's how we talk about stuff. In terms of inventory, there's two types of things you can put in inventory. There are hosts and there are groups. And inside of each of those respectively, there are host vars and group vars. And this is where you'll put a lot of configuration that is going to be specific to the machine that you're deploying on, maybe not specific to the applications that you're deploying. And finally, there's YAML. This is the elephant in the room, so to speak, because lots of people think that it's a programming language they need to know. They look at it and immediately they are turned away by it. This is too complicated. I can't learn this. But all you really need to know about YAML is that it's composed of three things. And the first is key value pairs, and they look like this. So over here, we have a key, and we have its value, and it's separated by a colon. That's a key value pair. The next thing you'll run into are lists, and they look like this. This is the name of the list, followed by a colon, and then underneath this list name, indented, and indentation is super important in YAML, there is a hyphen followed by all of the values that you need. So each one of these lines right here is another item in the list. And finally, there are dictionaries, and they look like this. This is the name of your dictionary, and dictionaries themselves can contain any number of key value pairs, lists, or dictionary or subdictionaries. So in this case, I just have a dictionary that has a number of key value pairs in it. Here's a key value, et cetera, et cetera. And also note that this is indented. Now the final one here, I said there were three, and technically there are. That's because the final one is combinations of the above. So here's an example of using all of these different things within a task list in Ansible. We have tasks up here, which itself is a list, and we can know that because the items underneath it are moved over and they start with a hyphen. And each one of these items in here is itself a dictionary. So this is one dictionary here that has a key name and a key OS network, and OS network itself is a dictionary that has a key of name and a key of state. This one down here, key value, down to list, and now we have a list of items, okay? So the architecture of a playbook. This is a very basic, typical example of what a playbook looks like. One thing to note, I did mention the indentation. This stuff right here, this indentation, is always spaces. It is never tabs. So don't you ever go putting tabs in there. We put spaces in there. You can choose 2 or 4, and all the haters that want to hate on spaces can leave the room right now. So the playbook. The playbook is just a file. In terms of syntax in Ansible and YAML, that doesn't exist for a playbook. A playbook conceptually is just a file, and it contains a list of plays. The playbook is consumed by Ansible, and it's what you specify on the CLI when you're using Ansible. So Ansible comes with some other tools for pulling data or running individual roles or individual modules, but by and large, if you're doing mass configuration and deployment of stuff, you're going to be consuming Ansible in its playbook form. Next is the play. The play is what contains the blocks of things that Ansible needs to run. It's chunks of work, such as tasks, roles, variables that you might want to define, prompts, etc. And these are all things that are essentially defined by Ansible, the product. And there can be many plays in a playbook. You're not limited to just one. You can put as many in there as you feel comfortable putting in an individual play. And if you need to make more plays, go for it. Next is tasks. Tasks contain the module as an argument, and they have their own specific arguments for doing things such as returning content of modules, looping, handling errors, retrying, stuff like that. In terms of the module developer has no control over this. You get these for free, and you will use them in writing your playbooks. This is not the domain of the module developer. So if something's not working, it's probably, and it's here, it's in Ansible core. And again, like there are many plays in a playbook, there are many tasks in a play. Modules. These do the actual work. They choose their own parameters, and those are defined by the module author. And so it's either I'm sitting here defining what they are, or I'm getting feedback from PMs or the field, and they're telling me what they should be. I decide what these parameters are, just as you would decide if you were writing your own module. The way that they work is that they're SCP'd over to the remote box, executed and deleted all in the same command. And so this allows no artifacts to be left on the remote machine, unless you ask for that. So you can instruct Ansible to leave the artifacts on the remote machine. And reasons that you might want to do that include, well, I need to debug something that didn't work. And network modules include their own special connection parameters, which we'll go over. So now that you know the terms, we're going to have a quiz. What is that? In the terms that we discussed, not things like lists, key value pairs, dictionaries, etc. The terms that we just discussed. If this is our playbook, what are we looking at right here? As identified by that. That is a play, correct. Yes. How about that? What is that? That's a task, yep. How about that? It's not a list, it is a dictionary, but in terms of the terms that we were just talking about, that is a module. Yes, correct. How about that? It is a parameter of the module. Good answer, because I was expecting to hear a parameter. And while parameter is technically correct, it is specifically a module parameter. Now, what is that? It does store the output, but in terms of what we've been talking about, what type or what is that? I'll give you a hint. It's a parameter, but it's not a module parameter. It's a task parameter, yes. And so the module developers have no control over that. That is given to you for free. For every module, you can use task parameters. The realm that we operate in, F5 with our modules, is like these lines right here, the module and the path, the argument. Cool. So yeah, let's go over some demos here that we got that I can show. The first one we're going to cover is licensing big IP. Now, licensing big IP is something that even our own engineers think is kind of complicated sometimes. It's not, and we're going to show you. So we have a number of licensing modules. The one we're going to be looking at is big IP device license. It takes two parameters that we care about, the license key and the license server. And note that it defaults to activate. So activate is F5's public license server. You really don't need to specify that. And so in addition to that, we also, I'm going to stub some stuff out here. The keys and some values, some generic values here. Something to, yes, that's a super secret license key. Works on all big IPs. And I also want to specify an accept EULA value here. This is required for the module. And it's required because our lawyers say it's required. So we provide links up here to our EULAs. And you can visit that. And I'm not going to assume that anyone treats EULAs, bad. I'm sure we all read them, so there it is. This is to prove that I have nothing hidden up my sleeves with the unactivated big IP. Now, I'm going to add some extra parameters here, and this is the connection parameters that are specific to network modules. This is probably going to be changing in future Ansible work because they're still trying to flesh this out. But I provide the connection parameters to the module so it knows how to get to the big IP device. I run the Ansible playbook command. I give it an inventory and a playbook file, what we just wrote, what you saw we just wrote. And then Ansible is going to go through this triple for loop of looking at each one of our plays, for each one of our hosts, for each one of our tasks. I only have one host here. I have one task, and I have one play. So I'm going to do essentially one thing. Now, Ansible starts by doing something called fact gathering. So this is done automatically, and you can turn that off, but in our case, we just left it on. And now that the device is licensed, we can see that TMUI here has restarted itself. This is pretty typical. And coming back in, we see that the box is now licensed. Right? So pretty simple. Some caveats with the current rev of the device license module is that it specifically only supports individual license keys. So subkeys and add-ons are not something that it can do yet. And And to answer another question that somebody asked in the previous session is the module instructing the big IP to license itself, or is the module doing the licensing? And the answer is the module is doing the licensing. You don't need your big IP connected to the internet to do any sort of licensing of its device. So this allows you to license your devices from your Ansible controller in a sort of lights out environment. Cool, let's move on to the HA pairing one. So this HA pairing example is kind of like a zero to hero example. It's pretty plain, and it's only going over stuff that you would probably do on like a day zero implementation of HA. All of the examples that I'm showing up here and the demo that Forrest will show, we have some of them in the examples folder here of our GitHub page. Forrest will probably be copied over there as well. So if you want to see what we're doing here, you can see this is the exact code that we're running. And I'll go over in this particular case some of the things that you need to fill out. So if you were to use this, we suggest that you either git clone or download the zip file that we have here. I'm going to go ahead and create some big IPs in our environment. I'm using OpenStack just because that's what I have available to me. It's irrelevant really what your infrastructure is. And so I'm going to just create a simple heat stack here that has 2 big IPs in it. And these ones are running 13.107. But the modules don't really care. Our Ansible modules support everything from 12.0.0 beyond, unless it specifically calls out something that doesn't exist. So for this particular example, I have some group vars and I have some host vars for my 2 hosts. My group vars here are basically the connection parameters, and in my case, they're the same for the hosts. I also have an Ansible Python interpreter line here, which in your case, if you're going to do this, it is probably irrelevant. I have to use it for my environment. But normal Python on a normal Linux machine should be sufficient. The other thing here is I've spelled out a number of placeholders, these IP, A0, A1, A2, A3, et cetera, what are those and where do you find those values? Well, in your infrastructure provider of choice, whether it's bare metal, cloud, private cloud, whatever, it's going to allocate these IP addresses for you, or you're going to have them allocated somewhere in like an IPAM that you could provide to Ansible. One thing to note is that depending on the infrastructure, sometimes it likes to reorder these. So you have to pay particular attention to that, because if you mess up the order of these IP addresses when setting up the VLANs and the HA and all that, HA is not going to work. The playbook will fail, and the big IP will just not be in an HA configuration. So this last one here for the HA interface, I'm just duplicating the IP addresses for my config sync and mirroring, et cetera. Question?
What is the order you're talking about? The first one being management and the second one being?
So A0 in this case was the management IP address, and then A1, 2, and 3 were 3 extra interfaces like self IPs. So 1.1 interface to 1.2, 1.3. And then running it is the same as we ran every other playbook. Ansible playbook, give it an inventory, give it a playbook file, and away it goes. Now, in my particular case, Ansible didn't need to do anything for these first couple steps because that was actually taken care of by OpenStack. But these other ones down here, Ansible did need to do some work, and you'll see how it says changed there. This one, gathering facts, it's registering as no change, but that's expected because that's just getting data. It's not changing anything on the actual system. And we can see that it's awaiting its initial sync up here, and eventually it becomes in sync. And down here we're done. So that's your day 0 HA configuration for your big IPs. And then our final demo here, which actually follows up on the meeting that was in this room previously, was BigIQ applications. So this is something new in BigIQ 6, I think. And it pairs with the cloud, what do they call them, Cloud Virtual Edition. So this is an example of an existing Ansible playbook that I have. And it has a number of tasks in here, and some people can get a little overwhelmed having to write all the tasks or walk through what actually needs to be configured. So BigIQ has a feature called applications where we can remove essentially all of that. Now I'm going to log into the BigIQ here, click on the applications tab, and for this particular application we're going to require these things called SSGs, or service scaling groups, and we're going to deploy something from the service catalog. The service catalog that's supported in Ansible today does not include the AWS templates up here. It just includes these 6 templates right here. So we'll add more to the modules as BigIQ team produces more. I also need this SSG. An SSG is just a way of telling BigIQ that I want you to essentially manage the scaling or the number of BigIPs that are deployed for this application. In this case, I'm saying that I need at least one of a total of 5. And I don't have any application, or my application I'm going to deploy is not deployed yet. So we can click on an existing application. And the way I like to read this is from left to right, which says that, like, here's some inbound statistics about the client connection into the BigIP, and then some more statistics of how the BigIP load balances the traffic and the latency to the servers in the pool. So if we were to look at this in a block diagram-ish sort of thing, the way that our stuff is set up is there's a tier 1 BigIP that will send requests to a tier 2 BigIP, and then those tier 2 BigIPs are set up to have WordPress servers as a number of pool members. In terms of modules, these are the modules like we saw. They match essentially the things that you saw in the service catalog. And we're going to do a lot of the same work that we saw for the licensing thing and for all of the F5 modules, where we're going to stub out some of the required parameters and then start filling them in. So my provider is, again, a set of variables that I've defined above here. I'm going to create this app. I'm going to specify an inbound virtual, which is essentially your virtual server. And I'm going to specify a number of servers, which in this case would be the pool members, my back-end servers that I want to forward the traffic to. And then finally, I'll specify my service environment, which instructs BigIQ on where it's going to deploy it. Does it deploy it into VMware? Does it deploy it into AWS, Azure, et cetera, et cetera? So the application developer just shows up and is given the information of, like, you should deploy it here, and then the manager of BigIQ is responsible for creating those SSGs. So we can see here that it has deployed. It's red, and that's because the backing pool members, when we record this demo, were not real. And so it's trying to monitor stuff that doesn't exist, and it's saying it's down, which is fully expected. Okay. So Forrest is going to go after a live demo if the demo gods smile upon him.
Much luck. So I have a repo that's available right now, and the purpose of cloning it in front of you is so that you can see that you only have to edit a few files, and you could use this today. And what this is going to do, sorry about my mic, it seems very randomly staticky. This is our environment we're working with. We have 2 data center BigIPs, Zone 1, Zone 2, and then one in AWS that's going to be fronted by an elastic IP, and it should be reachable by the end of the playbook running to everyone in the class.
Yes, this is an interactive demo.
Yes.
So we want you all to interact.
The idea here, though, is it's going to take a small input file. So this is all you're passing it, this one file, and it's a little small. Let me zoom in. But your name of your application, example 1, then your subdomain, your data center, Zone 1, Zone 2, AWS, the IPs, and then AWS has a EIP section right here where it will be a public elastic IP on AWS and make it reachable. So all the steps, all the files I'm going to edit are step-by-step in this repo too, and it's really not that much. That was it right there. There's not too much to it. So you can see our host file here. We're defining Zone 1, Zone 2, AWS as LTMs. We're defining a GTM as AWS, and then we have our Python interpreter, which we were talking about before. And in the demo, I'm going to customize that to the one that I'm running. So let's go ahead and do that. I'm going to clone the repo. Where am I? There we go. And it is not showing up. Okay, so here's our repo. We just pulled down the files. Here's the host we were just talking about with the Python interpreter. I have my custom one right here with the interpreter slightly different, and that could be unique to your environment, but most likely your environment will be fine the way it is. We have our devices, and then we have our host vars. And Tim was talking about this earlier. So for each one of these, we're defining our connection parameters. Let me zoom in. We have our connection parameters, IP, the username, the password, and the password itself is a variable which is being read from this vault file, which will show you how to encrypt and how to connect to the big IP. And there's one of these for each, Zone 1, Zone 2, and AWS. So I'm going to just drag my host vars over here with its specific passwords, because I don't want everyone in the room to know my password to my AWS LTM. Not in this case, I'm not, no. Yeah. Okay. So we have our vault passwords, they're in clear text. Let's just encrypt those real quick. And again, this step is in the repo, and it has more information about vault and inventory and so on right here with the command. Okay. So to encrypt the password files, there's an Ansible vault, encrypt, host vars, zone 1, vault, and that's the name of the file that we want to encrypt. And then we'll do host vars, zone 2, vault, and then host vars, AWS, vault. And we should see the password files now encrypted. And the last thing we want to do is take our specific environment. So you saw on the repo, it had just a generic name up here for the subdomain, but we actually want it to be reachable. So we have super netops, E to E, super netops is the domain. So we're going to take our app template up here and update it with our environment. So again, this is something you'd have to edit for your environment, your VIP IPs, your AWS IPs, and your EIP, and this is what will be externally reachable afterwards. Okay. So now the last step is to run our playbook. And very similar to the commands before, we're just specifying our host file, what we want to use, the playbook name, and then the app template file that we want to use, which is app1, the one I just had on the screen. Ask for the password to unvault the passwords. And here it is going out to each one of the hosts defined in the app locations here, zone 1, zone 2, creating the pools, creating the LTMs, adding an iRole to the boxes, going to AWS, and so on. And then it goes into GSLB objects, the wide IP, the pools, and then it's doing a dependency where the EIP availability is dependent on the internal IP of the AWS VIP. Really the highlight here is to show the power that you can have a simple input file like this, and if you can just copy and paste this multiple times, then you can repeat applications multiple times. So
now this site should actually be accessible from your cell phones, from your laptops, all of that.
So if anyone wants to try example 1.e2e.supernetops.com, right now it shows as a phone right there, but I have my host headers faked. So if I take off my user agent as Android and refresh this page, it'll actually show a laptop here instead as my accessing device.
Question?
Will you, should say how this is, will you have a demo or something that shows, like, showing iRule doing recursive proxies?
I'm sure Forrest could put something together like that. Do I have we don't have an example for that.
Yeah, not
Yeah, and our examples directory, I don't believe has an example of that, but we'll take that as feedback and add something.
Yeah, thank you. So here's the wide IP, and you can see that it's green if I go into it. The local data centers will be down. I did not provide a tunnel for my AWS GTM to reach my data center LTMs, but here you can see the 2 local data centers are down, and then we have our elastic IP right here. If we click on that, you'll see that it has a dependency on the VIP that was created. They have internal private IP VIP And now you have an application that is both spanning internal and external with a single playbook variable file provided. And this is, you can download this now. I'm not saying it's the perfect way to do things. It's
Sure.
an example of what you could do using Ansible, right? PowerPoint.
Question?
Yeah. You mentioned your YAML file. You're actually copying that over?
The YAML file, when Ansible is going to eat that YAML file before anything's copied over to machines. It's going to translate that YAML into Python, and then it copies the Python file over to the remote machine, which in our case, for F5 modules, is the Ansible controller. So
It's
it
itself,
copies
yeah.
itself.
Right, but it's, so it's the F5, it's a Python file.
Yep.
And then what initiates the run of the F5?
It would actually, so on the F5 specific example, it's actually sending REST calls to do the change
Yeah, so-
from the Ansible. So the Ansible host machine talks to itself, then sends the REST calls, right?
I guess if I were you, I guess it's not a file, right?
Uh-huh.
You're doing SSH.
Correct. The normal operation of Ansible historically has been an SSH connection to like Linux servers, or in Windows cases it contacts WinRM.
And again, it's transmitting this Python config file.
It's in our case it's sending over a Python file, yeah.
Yeah.
And then Ansible instructs the remote machine, which in our case is the Ansible controller, Python space this file that I translated, and RM this file that I translated. Yep.
But
Yep.
that file is REST.
It's REST. Yeah.
Yep.
So we have one module that can do SSH, and that's big IP command. And that's really kind of just a fallback for the other modules. If you can't do something and you don't want to result to like Ansible's URI module, because that would have you directly interacting with our REST API, and you would have to own all of the quirks and stuff associated with that, you can use big IP command to run TMSH commands directly on our box.
Great catch-all. First, if you have a small parameter you have to tweak. So then we want to go over just support, models for Ansible through F5. So we are actually the only third-party vendor that are officially supporting our modules, which we're pretty proud of. On our website, but also on Ansible's documentation, we have examples of all of our modules. And the documentation is actually within the modules itself,
Yeah,
which is very useful.
It's auto-generated.
So you can see an example, like if you look at a module, I'm not sure what parameters to use, there's a few examples on every single one of them.
Yeah, and the examples that we include in the modules are usually like the 80% case. So if you're going to use our module and you're likely going to do this with it, then we usually paste those in there. So if there is something that you feel is missing that a lot of people use, then we can add those to the module docs.
And then, so there are a few ways to engage us if you're having issues with things or you have feature requests for modules. One is obviously through sales, but then another is through just directly opening issues on GitHub. And I think before we go into the troubleshooting, we might as well bring that up real quick.
Yeah.
So F5. So if you look for F5 networks and F5 Ansible, here's our repo of our modules, and I might as well just show you real quick. Here's a listing of all of our modules, right? So sync, device auth, data group, and there's quite a few.
Yeah, so this
Tim's
is
done a lot.
This is our development code, and in terms of support, what is supported is our stable code. Stable code is what you get with Ansible. It's not what you get from here. This stuff right here will always be a step ahead of whatever's in stable. And towards the end of every Ansible release cycle, we essentially try to true up this with stable. So an Ansible release cycle is typically quarterly, and we'll do a lot of work, and then towards the end of that, we'll just merge all of that code into the core product, and then that's when you get it when 2.6 or 2.7 comes out. We generally don't do updates to like the patch releases. So 2.6.1, 2.6.2, 2.6.3, we don't usually update stuff in there. We go to the next minor release, 2.6 to 2.7 to 2.8, etc. That's not to say that you can't use this. There are some customers that do use this. It's just that the trade-off for them is we're sufficiently knowledgeable or technical with this product that we don't care to use the stable one. We're going to take it into our own hands and use it like this. Generally speaking, these are pretty stable. But again, F5 support strictly is talking about the stable stuff that you get from Ansible.
Yep. So if you come to this repo and if you have an issue, you feel like you're running into a bug, or you have a feature request, or you can come in here and there's a new issue at the top and open up an issue.
So this is essentially what we expect from you. If you're going to take the time to write this file and issue, we're going to need some information from you. And we've organized it in a template here. So the template is, do you got a pointer?
Is it behind here?
Yeah. So the way the information is organized is this is Markdown, and the headers here are hash signs. So if you scroll up a little bit, the first thing that we're asking you for is to please specify what you believe the issue is. Is it a bug, is it a feature, or is it something that you're reporting on the documentation? You can just delete the other ones and leave the one that you believe is the case. The second thing here, component name, this is what module you believe is broken. So if you're using a particular module, it's raising an error or a Python backtrace, something that the playbook is stopping right there, you can just place the name of the module in here. This allows us to know exactly what the problem is. We can go look at that module. Next, the Ansible version. So we give you a command that you want to run here on your CLI, Ansible-version, and you want to paste the input or the output of that in between these 3 backticks, or these 2 sets of 3 backticks. That'll just make it look better formatted, so that when you see it and when we see it, it doesn't just look like a bunch of text scrambled on the page. We're also interested in the version of Python that you're using. Again, we give you a command up here that you can run. You paste the output here. This allows us to narrow down if it's a Python-specific problem. The big IP version with the TMSH command and the output that we're interested in there. And the reason, again, is because we support from 12 to whatever our current release is. And some bugs are specific to the version of big IP. So if you don't specify one, we're going to test it on the latest release of big IP, and we might not see the bug. So we need to know that. In this case, we're also asking for library versions. So we have a pip command that asks essentially for the version of Big Suds and F5 SDK. And if there is configuration that has changed in your default Ansible config, you'll see that, because any mention of if you've tweaked your Ansible.cfg file, we might need to know that. And the reasons that we might need to know that are, for instance, if you're using development files or you've copied stable files and put them in a different directory. Sometimes Ansible can get confused on which module it's using, and that helps us answer questions. The OS that you're using, if you're trying to do this on Windows, it's probably not going to work. We test and develop all of our stuff on Linux-based stuff, but you might see quirks if you did it on other operating systems. Give us a summary of what you think the problem is. It's not working is not a good summary. So I tried to do this with this and it didn't work, and here's the output of it. Any steps to reproduce? What we're really interested in here is the task. So the task that ran that failed. That can be really helpful in us identifying what the problem is. The data to that task is not necessarily important insofar as we don't need your exact data, but we might need something that looks similar to it. So instead of your actual domain name, you might put foo.bar.com. Unless you actually are bar.com with a foo server, then you probably wouldn't put foo.bar.com. But you get the idea. We don't need the exact data. We need something that resembles something that's similar. What you expected and then what actually happened. So the output of like Ansible-playbook. So we can actually go look at some existing issues if you want to scroll up to the top.
I really wanted to open that issue to you. But
Closed, won't fix. So here's some issues. NeoZuluk usually opens some good ones. Why don't you click on the
first one?
Yeah, the first one. So this person's reporting a bug in the Big IP virtual server module. They've provided their Ansible version, the version of Python they're using. The Big IP version from the output of TMSH shows syssoftware, I believe. Their library versions, that it's a standard Ansible config. They've made no changes. The OS that they're running it in, the summary of the problem, some steps to reproduce it, some general data here, and the actual results that happened. So you see here that this error was raised. Ansible gives you a dump of what it got here. For some parameters like password, it'll mask those out. And then using this bug report, we can go narrow down almost immediately what the problem is. And at this point, it falls back on us to basically start communicating with you. We deprioritize issues that are drive-by issues. If you just come to GitHub, create an issue, and leave, we deprioritize those. We are looking for people that have some skin in the game. So you see these little emote icons right here. This is us communicating with you. So if you're not going to communicate with us because the email address you used when you created a GitHub account or something is not accepting mail or it wasn't real, then you're not going to be getting these notifications from GitHub, and we will have no way to contact you. In particular, if the account that you create has no identifying information about you. We don't require that you identify yourself, but let me see if I can click on my name. But for instance, like here's me identifying myself, okay? If we do happen to know who you are, it helps us a little more insofar as we can engage like your account manager or stuff like that to help you even more. If there's something that's really super specific about your environment, that's only about your environment, and we could have you upload a QK view to iHealth, and we can engage you through that mechanism. Obviously, SRs and stuff like that you send through normal support channels, they'll know who you are, and that allows us to find out more about your configuration without publicly mentioning anything on here. We're not asking for you to disclose anything publicly that you don't feel comfortable disclosing. So if that is the case, then a formal SR is probably a better approach. So let's quickly cover some troubleshooting things, and then we can call it. So all of these issues here, and we'll go over them, you can start reading through them, are issues that we consider to be like the top 10 problems you'll run into using our particular modules. And these sets of slides, I believe, will be available. The slides after this particular slide go into how you might detect that you have this problem and also how to solve this problem. And F5 support has been trained on how to fix these problems. So because we expect that this is going to be largely what you run into. So the first thing up here, running Ansible module on the big IP instead of the Ansible controller. Remember our first set of slides, we talked about how it doesn't SSH over, it makes that local connection. Well, to instruct Ansible to do that requires that you specify either a delegation to localhost or a connection to the local Ansible controller. And many people forget to do this. So what Ansible tries to do is it tries to run the module on the big IP and it fails. This is, without a doubt, the biggest problem that we see. Module external dependencies are not installed or up to date. In the past, this used to be a bigger issue because we updated the F5 SDK quite a bit, and people would try to use a new module with an old SDK, and they would get an error because some API was not known to the SDK. In this case, we just want you to make sure that you've used pip to update your dependencies and make sure that that's off the table as a problem. Using experimental code on a stable install. Again, this is, you are taking your fate into your own hands. It's not a supported way of operating the modules from F5's point of view. If you do need assistance with this, or this is the way that you want to operate, support is essentially going to be best effort through GitHub. Now we do quite a good effort, and if you have interacted with us on GitHub, we hope that you've seen that. And we're usually pretty responsive to fixing issues and at least responding to the issues to let you know that we are on the case. Running Ansible in a virtual env. This is something that's totally okay to do. It's a supported way of doing it, but if you're not familiar with how virtual envs operate, it's something that can throw you for a loop. The reason is because when you run Ansible from the virtual env, Ansible is again going to make that connection back to the local machine. But it's unlikely that the virtual env's Python is in your path when that happens, because using a virtual env, you have to activate it after you've already logged in. So the way to fix this is going back to that Ansible Python interpreter, just specify the path to the virtual env's Python, and that problem goes away. Unable to connect to the big IP when using your Ansible playbook. This one is also surprisingly common, and it's almost always because the password was incorrect, or the username was wrong, or the port that they chose was wrong. I mean, you wouldn't think, but it happens almost as much as the first one up here. The The way that we really troubleshoot this one is, again, we ask you to log into TMUI if you can. We ask you to curl from your Ansible controller to the remote big IP, a known API. And the reason is because essentially the modules are operating in much the same way that curl does. So if curl is proven to work, then the module should work, and we just need to like narrow down what you're typing in wrong. Port is another one. So in our cloud environments, if you're running single NIC, the port actually changes to like 8443. The default ports that we use are 443. So you might not know that going in, and that's why asking you to log into something like TMUI or curl, where you have to specify that, it makes it clear that you're missing that. Another thing that commonly happens is people try to run Ansible on their controller connecting to their big IP, and they discover that they either have to go through a proxy to do that, or there's a network firewall in the way that's blocking them that they didn't know about. Perhaps it's not managed by them. And so that's another thing that we see, the connections timing out. And we'll ask you, do you have like speed bumps in your network connection that would be preventing that? Oh yeah, thanks for reminding me. Misunderstanding the purpose of hosts. So Ansible can run things concurrently. And what we see people doing a lot of is they will specify a host of localhost, and then since the connection parameters are specified in the module, they'll say task 1, create a virtual server, and they'll say big IP 1. And then task 2 is create a virtual server and say big IP 2. And task 3 is a virtual server and big IP 3. That defeats all of the parallelism that Ansible has. The better way to do that is to have a single virtual server task and use hosts in the form of your 3 hosts or however many hosts that you have up there to fan out that configuration concurrently across your devices. It's going to speed everything up. You're not going to, I mean, Ansible's still going to be doing all the same work, but you're going to be taking advantage of how many simultaneous connections can Ansible make out of the box. By default, it's 5, okay? And it's dependent on how powerful the system is that's running Ansible. And then misunderstanding of expected values of parameters. This one creeps up a lot too, in particular with things that are lists. Sometimes the list is just a simple list, and sometimes our parameters take lists that themselves are dictionaries. So you might have to specify an address and a port, as opposed to just the address. This is all documented in the module docs. And surprisingly, the module docs are almost never consulted. So the way we troubleshoot it is we ask for your task and we go look at the module docs and we say, oh, this should be a list of dictionaries. You're just putting a comma separated value in there. So if you believe that is the case, this is something that you should go look at and read the module docs. What we expect is always documented in there. And then if there's anything that needs to be clarified, we usually follow it up with an example.
I mean, and so all of these, we actually also have more extensive use cases in the slide, so you can look through a little more of the examples. But just on time, we didn't want to spend too much on that. But when you get the deck later, it's available to you. So a lot of the examples Tim was just talking about, you can kind of see example errors of them, so that you go, oh, that looks familiar now. This must be what he was talking about. Yeah.
So in particular about this slide, our errors usually look like horrible like this. We don't specifically hide these errors from you, and that's because if you do run into a problem and all we were posting up here was, please contact your F5 representative, we would have no context here, and we would have to somehow get this information from you. So it's better that we just abruptly stop and puke all over the screen here than to hide that away and say, well, it's accessible in some sideband method that we have this other document you have to go read to get instructions on how to get. F5 and us on GitHub would be asking you for this anyway. So you're going to just copy and paste that and send it back to us. Okay, any questions? Yeah, in the back.
Any recommendations in terms of optimizing parallel connections?
Optimizing parallel connections. That is a tricky business, especially for like large configurations. So Ansible's parallelism is again based on host, but it's kind of funny because the host is an arbitrary string. The host itself can be, foo, bar, and com, and all of the IP addresses or actual host names can be the exact same IP address. So there's some like ongoing work to decide what's a good way to just have like large configurations pushed all at the same time. And you could almost get away with something where like your virtual servers are your hosts, but the IP address for all of the virtual servers that the Ansible connection makes is your big IP. So you could create 50,000 virtuals simultaneously, as opposed to one big IP that loops several thousand times. So there's tricks like that that you can use to optimize like the speed of the playbook deployment. In Ansible 2.5 or 2.6, they also introduced persistent connections, which we take advantage of, where that loop that we were talking about is only done once when the playbook starts, and then it's reused. It's never recreated after that. It's enabled by default, yeah.
What I was trying to get to is like, do you have any recommendation in terms of the goals of pipelining and things like that in the actual config file? Do you have any experience with that?
Well, so in a former life, when I worked for a large cloud provider, we had about 50,000 machines that we were under management, and we would do them in batches of 500. The reason being was because the engineering team, which was deploying these changes, wanted to deliver batches of work to the sysadmin team that would have to go remedy any problems with this. And usually somewhere in that batch of 500, you're talking maybe like 5 to 10 machines that wouldn't come back. So they would have to go find the machine, contact the data center, have them unrack it, contact the customers and say, hey, the machine's down during some planned outage, we're recovering it. You don't want to just go in all 50,000 and then hand them off to the sysadmins and say, away you go. So 500 is what we were running on a virtual machine. I think it probably had somewhere like 2 to 4 gig of RAM. At that time, before Ansible did like multiplexing of stuff, you might get into conditions where you ran out of file descriptors or open ports or stuff like that. I don't think that's as big of an issue anymore, though. Other question? Anyone? Does that answer your question? Okay. Anyone else? Yep. Is there currently support for ASM module? There's an ASM module to put a policy that you have onto the box. Yes. Correct. Correct. Yeah, and so ASM policies can be exported off the box in a number of ways. There's like the readable way in XML form, and then there's the binary way. If you want to get into the business of like kind of tweaking the policy per big IP that you're putting on, you have some general policy. The recommendation would be to use like the XML way, because you could put that into a template in Ansible and then use like Jinja stuff to change the actual ASM policy that's going out. Obviously, we don't have any idea how the binary one works. Someone at F5 does. It's not this team. Any other questions? So the MCM modules that you have, those are technically evaluations to that level? Yeah. Yeah. And if there are any exceptions, it's documented in the requirements in the module. So when you read the module docs, towards the top it'll say requirements, bullet list, big IP 13 or greater than or equal to 13 or something. When we have those cases, it's usually because it's new functionality that was literally introduced in that version. And so it's obviously not going to be backported to earlier big IPs that didn't exist. And the only other case where that might happen is if something is changed in big IP, and it's such a gigantic change that backwards compatibility is broken between 12 and 13 or 13 and 14, something like that. What we'll do is we'll prefer the newer version, because we know going forward that that's how it's going to be. And if there is reason to attempt to backport that into like another module or some existing module, we field those on a case-by-case basis. Yeah. Yeah, unfortunately 11.5 is kind of like the cutoff. 11.6 you might have more luck just because some of the REST APIs were better. But even when we were developing the Python SDK, we could never get like good, reliable REST API stuff on anything earlier than 11.6, I think. So, yep, TMSH, big IP command over SSH will work. Question in the back?
The AS3 API.
Mm-hmm. Yep.
The schema?
The schema, yeah.
Get the fax module, get it in that same format, or I'm assuming it's not that same?
The Ansible fax module doesn't return data in an AS3 format, although it's it's probably something that we could do. It would be, the problem with AS3 and getting facts out like that is that AS3 has a particular way that it puts configuration on your box. And that particular way revolves around partitions. But what we found is that many customers don't have existing configuration that's laid out in that way.
And that would basically be a parser that makes, at that point, AS3 declarations, which is not on the roadmap right now. I just want to make that clear. We don't have something that just can take an existing config and create an AS3 declaration out of it.
Yeah, it gets a little squirrely on how exactly that happens. But if you're going to use AS3 with Ansible, that's supported today. That's a URI module. Ansible's native URI module is the preferred method to do that.
So on my same repo, which I need to get into the shared demo one, it's an Ansible one that creates AS3 declarations based on the same input file and then uses those declaratively to push to the big IP instead of the Ansible modules themselves. So it gives you another way of using source of truth and creating that source of truth through a simpler method rather than writing out that huge declaration. Let's have Ansible create it for us using Jinja 2, right?
Right. Yeah. And if JSON's not your thing, because the AS3 schema is in JSON, if you float more towards the YAML side, you could technically write your declaration, your AS3 declaration in YAML, because Ansible has filters that you can change inputs to different outputs. So you could read in your YAML file, convert it to JSON, and then pass that JSON off to the URI module, and off it goes. Some people might prefer that because there's things like you can't put comments in JSON, commas are kind of strict in JSON. So it's personal preference, but Ansible would support either way. Cool.
Appreciate it. We almost talked till everyone left.
Awesome, great. Thanks a lot.